Hi, I'm Jim Bergman. Welcome to TruTech Tools Combustion Analyzer Bootcamp, an introduction to the Testo 327. TruTech Tools is experienced professionals delivering CEUs in our live training, 45 years combined experience, practical related hands-on training, and some earn what you learn CEUs. Today we're going to go over the importance of combustion analysis, an overview of the menus, the main menus, the measuring menus, the flue gas test measurement menus, how to adjust the adjustment menus, setup menus, fuel selections, diagnostics, calibration, some filters and probes, pumps and printers, and some closing thoughts. So why is combustion analysis important? Well, first of all, we want to verify safety of the appliance before and after servicing. And this is especially important as we weatherize homes and tighten things up. We want to make sure that we're not creating an environment that's dangerous. We want to calculate the combustion efficiency and see what that's running. We want to monitor the pollution the appliance is producing, whether that's CO or possibly NOx or SOx. Verify conformance with manufacturer's guidelines and make sure it's operating safely. And minimize warranty issues and ensure equipment longevity. Complete combustion, when we talk about, what does the analyzer do? Well, first of all, we have to start with some science, and that starts with what is complete combustion. And here's what I want you to pay particular attention to. Number one, oxygen is the oxidizer for the fuel. Okay, now we're talking about oxygen, fuel and heat. So we have oxygen, fuel, and heat. And the heat in this case is a source of ignition, the spark, pilot, whatever that is. Complete combustion produces heat, carbon dioxide, and water vapor. That's it. There is nothing else produced. Heat, carbon dioxide, and water vapor. We have the complete conversion of carbon and hydrogen in the fuel into carbon dioxide and water vapor. Now, in reality, when we're talking about what happens in the field, we're using no longer oxygen as the oxidizer, but air. And air contains other chemicals in it, but it also contains the oxygen that's required for combustion. So we have air, fuel, and heat, again, a spark or pilot, and that's going to produce some kind of incomplete combustion, which is typically heat, soot, carbon dioxide, possibly carbon monoxide, water vapor, some toxins like NOx, SOx, or acids, and then we also have some excess air that goes through the combustion process that's required for safe combustion but not necessarily consumed in the combustion process. Combustion analysis involves the understanding the relationship of the gases and their combustion processes to determine proper operation so we can make adjustments as required for safety and efficiency. The efficiency calculated by the analyzer is actually a modified equation, and it's part thermal and part combustion, but it considers combustion efficiency and stack losses. Complete combustion analysis involves testing all the appliances, the venting system, the combustion air zone, the building envelope, and worst case testing. Now, what's important to realize is you can't just stick the probe in the stack and push buttons. There's no easy button. It requires some training. And we do have some advanced training in combustion if you're interested in that later. So let's look at the 327 at a glance. It's simply one of the best analyzers on the market for the money. It's designed for residential and light commercial markets. It's easy to use. It's got a real long sensor life, customizable menus, field serviceable, incorporates NOx filters. It can measure differential pressures, can measure differential temperatures, can print the results with an optional printer. And let's just go over an overview of the basic features. So on the top of the instrument is our power button. That turns the instrument obviously on and off. We have a drain plug also on the top, and I'll show you a view of that in just a second. Our display, a 4-segment display that's user configurable. Soft function keys, and they call those soft function keys because the function changes with the center 3 options in the bottom of the digital display. Our up and down arrow keys to scroll through the menus. Our menu key that gets us into the menus for our different features or diagnostics in the instrument. Escape key, which takes us out of the menus. Our air temperature probe, which on the bottom there, that is a removable probe, but that cage that's shown there is the one that comes standard with the instrument for ambient air temperature. Our flue gas connection, our charger port, differential pressure port for the manometer, our backlight key, and then we're looking at the bottom here and top of the instrument. Now, if you look at the condensate trap on the left, there is a max fill line, and then you'll see those 2 little white beads inside. Those are to sense when the when the analyzer is full of water and it needs to be drained. You should drain it long before then. Keep an eye on that max level line because you don't want to get water in too much water inside the analyzer. And we're going to top view at the top section of the screen. There's a power button and the IR output for the printer and the pull for the condensate. Important note, that thing pulls out but doesn't pull all the way out, so you don't want to pull that all the way out or you can damage that. Our ambient air temperature probe on the bottom there. Our exhaust vent is where the flue gases go out of the instrument. You got to realize you're pulling flue gases through. We're sampling them. We have to exhaust them back out. And our positive port for the manometer, the negative port for the manometer, and the charger port. On the back of the 327, there are 3 very strong magnets which will attach that to the to a furnace while you're working on it. And we have the access door and we have the manufacturer's label, which includes the model and serial number and the date code the analyzer was made. If you pull the back off the analyzer, you'll see inside the pump, which is a replaceable pump, a rechargeable lithium-ion battery, a pressure sensor, which is a manometer, your O2 and your CO cells, along with the incorporated NOx filter. When CO readings matter, and it really always does, you never ever want to measure without a NOx filter. They come standard on all Testo units. They typically last the life of the CO cell, but without that, there's errors of 40 to 80 ppm high possible. So, whenever CO really matters, if you're doing weatherization, you're doing furnace testing, make sure you're using a unit with a NOx filter. Let's go over the main menu. So again, this is where all the measuring tests are performed, where we can adjust for field calibrations. We can do setup mode for configuring the analyzer, fuel selection for the fuel selection, and diagnostics for troubleshooting the meter operation. In the measuring menu, all these menus wrap around. So if you scroll through them, you'll get right back to where you started at. And specifically, we're talking about flue gas, draft, CO air free, smoke oil derivative, differential pressure, delta temperature, ambient CO. Flue gas, when we get into flue gas, it's the properties of flue gas is measured and calculated, used for field diagnostics by the technician. That's what, in a measuring menu, that's what you do with those with the flue gas measurement. If we're talking about draft, we're talking about measure of pressure within the stack with regards to the combustion air zone. CO air free is a measurement of the ambient CO with reference to oxygen remaining in the flue gases, and this is typically used with ovens and stoves. Smoke oil derivative is a user input spot number derived from the manual smoke spot test. It's averaged and stored. Differential pressure is the difference between the stack probe negative and the pressure port. It can also be used with an adapter for static pressure or for combustion air zone pressure measurement or static pressure, and it can also be stored. And then differential temperature is the difference between the stack temperature and the thermocouple ambient air probe. And this is also what we call net stack temperature if measuring the flue gas with a combustion air probe, and it can also be stored. And then ambient CO is the ambient CO level of the air with respect to an O2 concentration of 20.9%. Draft. When you make a draft test, and upon startup, it's got a 0 for 5 seconds, and draft can be measured in inches of H2O or pascals, amongst a whole bunch of other units that they have in there. But typically, we're going to use inches H2O in the HVAC industry. And while you're making that draft measurement, we want to try and find the hottest spot in the stack because that's where the draft is going to be at its highest. Real important to notice up here, if you look at the mouse on the screen there, you want to draft test above the draft hood. The draft hood separates the appliance from the draft. So we draft test above the hood, we combustion test below the hood. Okay, so in that hood is where the dilution air goes in. So a combustion test requires an undiluted flue gas sample. And we want to draft test before the draft hood, where it's separated from the draft. CO air free is the next measurement I want to talk about, and CO air free uses the O2 sensor and the CO sensor to calculate undiluted CO sample. We use this in ovens and stoves and vent-free appliances, and it will not even start to register until the O2 drops below 18%. And so when the test is stopped, the value is recorded. But the key thing to remember when you're doing an air-free measurement is that Testo 327's got to be zeroed in fresh air prior to the test. Otherwise, you're going to get an error in your result. Smoke oil derivative. The smoke test, if you're doing oil work, can be recorded, and if desired, right on the meter so it prints out with your print results. And the smoke test is read manually by a technician. Then it's recorded. The oil derivative test is commonly performed in Europe, and what that is a test to see if oil, unburned fuel oil, is coming through. We're going to cover that in a little detail on the next page. So, oil derivative, what is it? Well, if heating oil is not completely burned, the flue gases can include oil derivatives, which are an environmental pollutant. Oil derivatives are organic substances. They're not volatile, that become visible by means of acetone application to the filter paper. So simply, after you take an oil test, you put a drop of acetone on the smoke spot, and if it spreads out to distinct yellow or brown, you have unburned oil in the flue gas. And obviously this means that we have a decrease in efficiency. Differential pressure. If you purchase the accessory adapter, you have a very high precision differential pressure manometer built right into the Testo 327. You can use that for measuring pressures across filters, heat exchangers, coils, checking pressure switches, setting gas pressure, or any other thing you'd use a differential pressure manometer for. Again, you got to remember when you start it up, you have to zero it for 5 seconds, and with no pressure on the ports. And then when you start the reading, it'll register on the display. When you push stop, that's what's recorded. Differential temperature can be used for temperized furnaces or boilers, and there are accessory probes for that. If you want to use the stack probe for one and another thermocouple for the other, you can remove that cage probe and slip one in there, and it'll measure your differential temperature. Ambient CO is used for checking the combustion air zone or for the rest of the building. The Testo 327, again, has got to be zeroed in fresh air, and you can use that stack probe during the measurement. The combustion air zone is the surroundings from which all the flue gases, surroundings from which the combustion equipment gets its air. So, that's the area where you're standing and doing testing, and you might also want to, actually you should also test throughout the house. Flue gas measurement test. So let's talk a little bit about that. So the flue gas measurement test includes stack temperature, includes the O2, carbon monoxide, CO air free, efficiency, excess air, dew point temperature, draft, ambient temperature, instrument temperature, delta temperature, differential pressure, CO ambient, and CO ambient. Again, you can't reinforce enough. You got to re-zero for any of these tests in fresh air before you make a measurement. So stack temperature is actually what we call gross stack temperature. It's ambient temperature plus the stack temperature. Our oxygen is percent of oxygen left in the flue gases after combustion, and that's ambient's 20.9. Carbon monoxide, CO, is a raw CO measurement, not corrected for dilution. It's what the CO sensor sees. So it's not a air-free measurement. Carbon monoxide air-free is corrected stack CO, taking into account how much that CO was diluted by the excess air. Efficiency is the estimated efficiency of the appliance, taking into account thermal and combustion efficiency. Excess air is percent of oxygen that's gone through the combustion process without being consumed. Dew point temperature is the temperature at which the flue gases start to condense. We've got to remember water is a byproduct of combustion. So typically in a non-condensing appliance, we want to keep that water vapor. So we want to know what the temperature is that'll start to condense. And then draft is our draft reading recorded in a stack during the test. Ambient temperature is a temperature of the combustion air zone, or if you're using an accessory probe, the temperature with the accessory probe. Internal instrument temperature is the internal temperature of the instrument, and they do some temperature compensation in there, so they have an internal temperature sensor. Delta temperature or differential temperature is a temperature difference recorded during differential temperature measurement. Differential pressure is a pressure recorded during differential pressure measurement. And then CO ambient is the ambient CO level with respect to an O2 of 20.9% recorded during the ambient CO test. We talk about the adjustment menu. That's really for factory calibration. That's your CO adjust and your O2 adjust. TruTech Tools is a factory authorized service center. You can also send it out to Testo for calibration and service, but we typically have very quick turnaround times. Setup mode. The setup mode allows the user to configure the display, and you can organize it in the way it's most important to you. In my case, I like to see, stack temperature, O2, CO, and CO air free are my first four. I really like to see because that's the measurements the analyzer's making, and that's what I use when I do a lot of diagnostic testing. It also allows us to set the user date and time, and allows us to set the language, English, French, or whatever else we want to set it to. Fuel selections. The Testo 327 has many fuel selections, including bioheat oil, which is a newer one, like vegetable oils or other mixtures of oil that are used for fuel oil furnaces. We got natural gas, propane, oil 2, 5, 6, kerosene, and wood in a Testo 327. And those fuel selections are really important for the efficiency calculations because each fuel has a specific and measurable heat content, and that's what's referenced from that variable in the analyzer. The diagnostic menu provides information on the model and serial number, the instrument internal temperature, the number of hours that it's been run. It gives us information on errors that, if there's an internal error like a CO overrange or something like that. It shows us the battery voltage. The continuous hours of runtime on the battery is about 4 hours, by the way, and a charge time of 5 to 6 hours. And then it also, the instrument can store some runtime and sensor overranges that can be read by factory authorized service. Combustion analyzers require a calibration about one time a year. You also want to have the pumps, filters, and probes checked. They're really, with all analyzers, as long as you drain the moisture out, you don't have to be too concerned with storing it in cold temperatures. But you got to realize is that an analyzer, warms up. Especially if it's very cold, it is going to impact its response time. So you want to take that into consideration. We really recommend you keep it up in the front of your cab and let it warm up as you drive to your first call in the morning. You do want to make sure that you periodically, when you're done with the analyzer, fresh air purge it, run it for a little while after and get all the flue gases out of there. And then obviously, when we talk about sensor range, we're specifically talking about CO. You do not want to overrange the sensors on there. It does have automatic protection, but you don't want to rely on that. You want to watch that CO, and if that CO really gets over a couple thousand parts per million, you may as well just pull that out of the stack and disconnect the probe because you don't want to damage the instrument by constantly overranging it. Batteries, you really don't have to worry about the proper type because it comes with the rechargeable batteries. But you do want to make sure that you don't leave it on the charger all the time because you can damage the battery. And periodically, you do want to run the battery down just so it doesn't impact the battery memory. We did talk about cold storage a little bit already. It does have an impact on the sensors as far as how quickly they respond. Same thing with LCD displays and batteries. You want to make sure you drain that remaining condensate out. The analyzer will take reasonable temperatures, but it will melt if you get it on a hot stack or something like that. So you want to make sure that when you stick it on something, you're putting it on a plenum or the front of the furnace where it's not exposed to high temperature. And you can melt the probes also, and the probe, the jacketing if you're not careful. And I've actually done that before myself. Filters. The unit is equipped with condensate and particulate filters. You want to make sure that you empty that condensate out periodically. I typically recommend after each use. There is a yellow particulate filter on the probe handle, and those get dirty from the inside out. So when that gets dirty on the outside, it's plugged on the inside and time to change. Typically with gas furnaces, they don't get dirty because there's really no particulate matter in the gas furnace. This is more of a problem with oil where you might get soot in the analyzer. If mine gets really saturated and wet, I'll pull it out and put a dry one in, but I'll just let it dry in the case and then reuse it. And when they get dirty, throw them away. But the filters will last a long time if you're testing gas appliances. Probes. The thermocouples, you just need to make sure that it's centered in the probe right and it's not subjected to any mechanical damage. You do want to be careful you don't strain the wires, and so just careful handling of the probe assembly will minimize wear and tear. Same thing with hoses. Is periodically you want to inspect that for cracks and holes. When you do get it calibrated, we do a leak test on it to make sure that you're not pulling any oxygen from the ambient air. So and periodically you just want to visually inspect those connection seals, O-rings, make sure they're in good shape. You can apply a tiny bit of silicone grease to the rubber seats on the probe connections. Just a tiny little dab to keep that connection tight. Pumps and printers. The pumps are replaceable. They very rarely ever break down. So, but they can get clogged, and I have seen them get clogged with something get stuck in the diaphragm, and it can actually pop that pump apart, clean the diaphragm off, and put it right back together. So it's not a hard job to do. We can handle that in service for you if you're not comfortable doing that. Printers, just make sure you have fresh batteries in the printer. You properly load that paper. You want to make sure you use the high temperature paper because and avoid use of office supply brands. Testo uses a long life paper that lasts up to 10 years. So standard thermal paper can go bad right in your dashboard in your truck. And use your head. Read the manual. Familiarize yourself with the analyzer before the season starts. Learn what to look for if the readings don't look right, which would mean like a really high O2 or a low CO2 reading is likely a sampling system problem, like a torn hose assembly. But don't lose faith in the units. They're easy to use, and you can understand it. Additional probes and accessories, some things to consider. The adapter for pressure readings is very handy. A hose extension, if you're doing like boiler burner work and you want to have the analyzer around the back, the probe around the back while you're around the front doing adjustments, a hose extension 9 foot is a handy thing to have. Combustion air temperature probes for 90 plus furnaces when you have to measure the entering air temperature and the stack from inside the house. So in cases, printers and all that kind of stuff are available, and even digital soot smoke pumps. So at the end of the day, combustion testing results, it saves time, saves money, avoids callback, limits your liability, maintains equipment warranty, provides confidence, increased comfort, increased safety, increased energy efficiency, and lowers our environmental pollutants. So thanks a lot for your time and attention to this video. And if you give us a product review on our site of this video, you can get a $10 gift certificate from TruTech Tools. And feel free to contact us at 888-224-3437 with any other questions, or visit our site at www.trutech.tools.com. Thanks a lot.